My name is Yacine, hello. I've done presentations to like equal numbers of people on Zoom, and it always looks like I'm doing it to only 10 people, so it's a lot less nerve-wracking. But I'll just go ahead and start. So hello, my name is Yacine. I'm a software engineer. I used to work at Stripe. I was on the ML team, but most of my career, don't tell other ML heads, but most of my career was doing IAM stuff, so like auth stuff. And I recently left my job to try my hand at a startup. So I've started a startup called Dingboard, and Dingboard is, I'll tell you a bit about Dingboard. So Dingboard's a very easy to use image editor tool. In fact, Dingboard is so fast, I used it to make this presentation about an hour ago. So if you guys want to fill in the time with questions, that would be great, because I did do this an hour ago. So you can find me on Twitter if you want to see me online. I would recommend not. And my presentation, so this is Dingboard. And my presentation is, can a solo unfunded founder, so unfunded for people who don't know is no VC money, can a solo unfunded founder beat VC startups? So a solo unfunded founder can definitely make an app without any funding. And Dingboard is basically a really crappy meme editing tool. It's really easy to use, and the core philosophy is basically how quickly can people churn out images. So that's Dingboard. I was supposed to stream this online, but I didn't, because that's really hard to set up. But I do want to mention that Ottawa is severely underrated. This is not a real quote, but I feel like Tim Ferriss thinks this, and I really like Tim Ferriss. So literal capital advantage. This happened like today, Sakana AI. They got a $30 million VC funding, which I don't really understand what that really means. And I wanted to talk a bit about what capital actually gets you today, and whether it's a competitive advantage, and whether it'll actually sink your company if you don't have it. And capital is pretty important because, well, GPUs cost a lot of money, and to do AI, you need GPUs. So we got Jensen over here blasting off into space because his GPUs are selling so well. Mistral was recently mentioned. They raised again, and the reason all these AI companies are raising so much is because the compute necessary to create these models to even just match the same level of GPT 3.5 costs an astronomical amount of money. It costs an astronomical amount of money not only on the compute, but on the data labeling, on the reviewing of the data, on the researchers, and on the sort of IP that those researchers create. So I'm here to tell you that there's hope. Small unfunded Ottawa companies can, in fact, fight against the giant coffers of American companies. God bless them. I really like my $5 Uber rides. And it's thanks to a few trends. So I want to talk about the trends, and if I could actually see what this one is. Yes. So one of the trends I've noticed is that models are getting really small. And the smaller that models get, the cheaper they are to run. And this is super, super important because you can basically serve more users with less compute. Because of how much demand there is for inference, all of these companies are incentivized to put out smaller and smaller models because commercializing them becomes a lot cheaper. And if you're trying to build a startup, that means you can build your startup on a single 3090 or 4090, which is only about $2,000. You see this here with like all of the models coming out of China. So Qwen 7B is actually pretty competitive with other models. Oops. Check. Yeah. So Qwen 7B, so 7 billion parameters is a pretty small model. That'll like run on like your son's gamer PC. It'll run on that. And this is pretty incredible. It's a this is a complete paradigm shift, right? Like GPT 3.5, GPT-3 used to be 175 billion parameters, so we're reaching the same amount of performance with a 10 times decrease in the amount of cost to run these things. Trend number 2 is the actual training for these models is getting a lot cheaper. So you can build custom models yourself. You can actually train these models on your own personal computer. Excuse me. So you can train these models on your personal computer. There's parameter efficient fine-tuning techniques to do this. So you can basically tune your models, train your models at home by yourself over a day. I've done this myself. And then trend number 3 is, this is actually from DALL-E 3's paper. So if you guys have used ChatGPT, you can generate images with ChatGPT. DALL-E performs pretty incredibly. And the reason it performs incredibly is because the data itself that's trained on. So if you dig into the paper itself, what they've done is they've trained a model to look at an image and describe it. And then they use the captions, the rich captions generated, to then train DALL-E. So we're hitting this loop right now where these models are bootstrapping on outputs from other models, which then has a huge jump in its performance as it relates to the size of the model, which again is cheaper. And if you don't have giant coffers and you're a humble self-funded Ottawa company, this is pretty good news. And as the data gets better, the models get super, super fast. So this is our friend Imad Mustik, and his corporation put up Stable Diffusion, so I'm sure you guys probably use Stable Diffusion. You can generate images with it. And this is a message he sent me, and he said, large compute is just an excuse for bad data. So as the data gets better, the models get more and more powerful and faster to run. And I'll show this off right now, actually. Give me 1 second. Please bear with me. So this is the speed of this diffusion that's going to happen right now. If Dingboard is up, again, I'm self-funded, so it breaks all the time. The speed of this diffusion is like pretty incredibly fast. So we put sunglasses on him, and that took me probably 10 times less than it would have cost me about 6 months ago because of LCM, which is, again, these models are getting better and better at doing the work with less compute. This is LCM. This is the thing that I just showed you with the in-painting. Effectively, you distill the data, you distill the learning from a larger model into a smaller model, and then you can do more work with less compute. These are some sample outputs from LCM, and you can kind of see here with less steps, you get a way better image than you would have otherwise, where you would have to have 32 steps, and that's like a factor of a lot. Like. It's actually quite incredible. So I'll stop here. If there's any questions, I'll run over and give you guys the microphone. All right, continuing on. So this is another trend, and I think that this is going to become, this is something that's going to become more apparent as time goes on and as these models get more powerful and as the software support gets better. So ONNX is pretty incredible. It basically means you can run neural networks anywhere. So it's this interop layer where you can export your neural networks. So normally you would train a neural network using some framework like PyTorch. What ONNX does is it allows you to create an ONNX model, which is basically this compiled down PyTorch model, which you can run across a various set of backends. So when I say backends, I mean running on GPUs or CPUs or even on the web browser using like WebAssembly. And this is great because I have no money because I'm not funded. And instead of using my own computers, I can use your computers. And there's a lot of people's computers out there. So this is going, you can kind of see this happening really quickly. So as I hover my mouse around, a neural network is running inference on my laptop. And this reduces the amount of work that I have to do on my own rented H100 from Land Labs by a large degree, and it increases the rate at which I can run the inference because I don't have to wait for the network to go from my web browser to Texas, America, which is my current rented web server, which I need to stop renting very soon. So trend number 4, I'm going to talk a bit about this because this is kind of my bread and butter, and my goal with Dingboard is to scale it. So I kind of want this thing to be like MS Paint, but to do that, I need a lot of computers. And I think I can just use other people's computers. That's my plan. So what I just ran was a task called segment anything. And to give you a good idea of segment anything, I think I would like to start with the first state-of-the-art model for segment anything. So the task is, if I have a picture of a dog, how many pixels can I highlight of that dog? And that, that area of the amount of pixels covered over the pixels missed or the false positives, that reduces your score a little bit. So the first state of the art was literally just finding a picture of the dog and coloring the whole picture. But as models got better, we started selecting more of the, I'm pretty sure that's a cat, not a dog. But that's the idea of the segmentation task. And it's incredibly useful for making memes really, really fast, because if you have a picture of, like, let's say Sam Altman and he just got fired from OpenAI and you need to take his picture and put him, maybe behind jail cells, you need to be able to segment his face off of an image. So the way the segmentation model that I'm using right now works is there's, first what it does is it encodes the image. And this is where, like, most of the work is done. And I could probably show it to you guys doing it. This is going to be kind of risky. So just refresh this, delete that, and then paste this here. And then you'll see that little gun here. It just finished loading, and a little bullet fell down. So what just happened there was the image was sent to my server in Texas, and a bunch of work was done. And that is actually the system effectively thinking and extracting signal from the image. So it's basically doing all of the pre-work necessary to do the final segmentation. And then the actual embedding comes back from Texas to Ottawa, Ontario, to my laptop. And then the final bits of neural network do the final work. So you see this lightweight image encoder over here, mask decoder, and the prompt encoder. So the prompt here is my click and the location. That happens on my computer. The lightweight mask decoder is a neural network that literally lives in this web browser right now. And this thing is massive. It is huge. This thing is a chunky neural network model. It lives in Texas on an H100. And by doing this, you can kind of focus down on these bits that need to be really fast and will suffer from network latency. And it's, I think, one way to, so this is from one of Jan LeCun's old presentations. I think a good way to understand image encoders is they're basically these large unsupervised models that are trained and literally have an understanding of all images and can optimally understand images. Often the way these things are trained is they do sort of mask predictions, so they mask parts of the images and they try to predict parts of the image. And if you do that long enough with enough images, it tends to have a pretty good comprehension of what things look like, which is pretty incredible and a bit concerning. So I'm going to do a quick time check. Okay, we're good on time. So again, you can do this with language as well. So that's how the word-to-vec models work. You try to predict a word based on the context around it, and you can extract features from words and project them out to latent space. And effectively, you can get these cool meaning maps of things in space and how to relate to each other. So hopefully that kind of makes sense about what embeddings are. But again, we get the embedding from Texas, bang, and it reaches Ottawa, Ontario, and we need to do the decoding. And I'll talk a bit about some optimizations I've done to make this happen a little bit faster. I've got 10,000 signed up users and probably don't tell my competitors, I've got 400-ish daily active users, I think. This is super unscientific. It's basically me grepping logs. But there was I keep on reaching these points where okay, this is actually getting too slow and people are complaining about it, so I need to figure out ways to make this go faster. So I baked in a job queue, and if you're not used to doing inference at scale, there's this great trick, and people use this on training as well. That's why GPUs are used for training. With GPUs, you can do a lot of work at once, as long as a lot of work kind of looks like the same. So as long as it's the same operation, you can do it across, let's say, 4 different things, or as much memory will allow, or as much as your CUDA cores will allow. So as you post an image to Dingboard, and you saw that sort of sniper rifle load up, what happens is that you post a job from your web browser, it hits a job queue, which I like baked. And when the inference worker sees a job in the job queue, it does like 4 at a time. And that increases the throughput by a large degree, a very large degree. If you're not going to do this, you are burning money. Because again, right now the main cost is the availability for these GPUs and how much it costs to like actually have one of them at any given moment. So that's my job queue. And you can do a bunch of different things with a job queue. It's also how I put sunglasses on your mod. Yeah, you know what? Let's do this. I'm going to show you the actual network cost because I think it helps drive it home. Okay, F12. That work? There we go. And we're going to look over here and make sure we have no filters. And then refresh that. And then I'm going to look for think. So you can like see here, I'm doing posting these think jobs, and then I'm procking for all of the done work, all the done jobs. And you saw there the bullets just flew off. That's because we have some work done, and then we get the actual embedding back. And I'm pretty sure I can show it to you on this response here. I know it's super small. Can you guys see this? I can't see this. I'm like right up here, and I can't see this. But you'll have to believe me that there's an embedding up here. Oops. I almost totaled. There's an embedding here, and it's just base 64 encoded, so it's a bunch of strings. It looks like a bunch of strings, but that is an array of numbers, and that somehow represents the meaning of the image. Trust me, I am surprised as well. This is a Lambda Labs hyperplane. Yeah, this thing is super expensive. I cannot afford this thing. I can't afford used computers off of Kijiji. This is actually, if you need workers, inference workers, use computers off of Kijiji. So good. 3090s out the wazoo. And the great thing about this like worker abstraction, or this job queue abstraction, is that you can basically point any worker at it. And you don't really, networking isn't really a pain because technically all you're doing is like polling some public API with some API key, and you're just getting some work done. So this effectively helps me scale at smaller increments, which as a self-funded founder, I kind of have to. So I did a quick time check. I think I have until 7:45. So yell at me if that's wrong. And then I'll stop here for any questions. Please don't be shy. Oh.
I was curious to hear about the latency of how long it takes to process an image and how long it takes you to reload your model onto the GPU. Because I imagine you're sharing it with other people, so every so often you get kicked out. So what's the time cost of processing an image versus loading the model back onto the card?
That's a really, really, really good question. The one thing I will never, ever give up is latency. The last thing I want to do is someone to be waiting on my interface, which is why I pre-can things and send them off. I actually have a bare metal server. It cost me $2 an hour from Lambda Labs. And I never load models on and off. And I'm going to talk a bit more about how you can avoid that with sort of clever tricks. But effectively, model switching is super expensive and it'll kill your latency. I think my jobs get posted and done in probably less than a second. And I think most of it is actually network latency and as measured from the client. So like the actual embedding is massive, it's huge. It's like 4.6 megabytes. And I could do work to make it smaller, but I think that's where most of the time is spent right now, is actually downloading the embedding. I think the model's like probably like 3, I don't know, like 10 gig, I don't know, it's a big vision model. I don't know, but yeah, like I've never gotten kicked off. I will sooner figure out how to run it off of my own laptop than get kicked off because it's really hard to get a GPU these days. That's a very good question, thank you. So I want to call back to trend number 3. Remember what I said about DALL-E 3 getting better because it's training on model outputs? Well, yeah, that happens with the same model, which is crazy. It's like you can just train a model, have it annotate data, and then retrain the same model on the annotated data that it annotated itself. That's segment anything. That's the same model I'm using here. We're back. Okay. Yes. And the great thing about this is that there's basically a trade-off on how much data you use and how much compute you need to make a model reality. And they're getting smaller. So this is FastSAM. It's pretty fast. It runs on like a CPU. And then there's mobile SAM, which runs on a mobile phone. This is like the whole model will run on a mobile phone. And then, again, efficient SAM, which is even smaller. And I actually, yesterday, I really wanted to get this done today, but yesterday I got the whole pipeline running on my browser. It takes about 20 seconds to decode an image, and I'm pretty sure that's because of the way, I think there's like some certain ops are just like really for convolutions or like really inefficient. But this is ONNX, and I basically just like took the PyTorch model, exported it to ONNX. It's really easy. You just export it to ONNX, and then you just like load it in the web browser, and it actually just works. It's crazy. And what I expect to happen in the future is the software support for this is going to get better. We're going to get web GPU support. So web GPU basically gives browsers access to your GPU, and Microsoft software employees are working on ONNX every day, and they're adding better and better support to this stuff. So I actually expect this to actually get faster as well. And another thing I've done is, it's crazy what you can do with a web browser if you look, but you can spawn different threads off of a single tab, and you can basically do 12 jobs at once. So I did say it takes 20 seconds to decode one image, but it also takes 20 seconds to decode 12 images if you have 12 cores, because I can just spawn 12 threads and completely nuke your CPU. Listen, I'm self-funded, it's okay. Right, and these are the price differences between the 4090 and H100, but you'll see like the main limitation is actually the VRAM requirement, and vision models I find do fit in 24 gigabytes of VRAM. Yeah, H100 is crazy. Those are like super fast. Let's stop talking about segment anything. Let's talk about the generation part. And I do want to like kind of compete on the generation part. So this is Midjourney. It looks great. I cannot believe a computer generated this. Dingboard did this centerpiece here, but the rest of the image was done by Midjourney. And Midjourney is really good, but there's a lot of things it cannot do. For example, Midjourney can't generate a bad-looking image, no matter how hard you try, because it only can generate good. That's what it was trained on. It's only trained on good-looking images. And if you wanted an image that didn't look good, what you need to do is download Comfy UI, 5 different stable diffusion models, make an insane pipeline, and do some in-painting magic. You can do it with stable diffusion. And I wanted to like basically talk about the trade-offs between Midjourney as a company and what Stable Diffusion does for the community. I really like that image. But you can go to sivi.ai, I think it was called, Civitai, whatever. But people can train their own models, and this gives you, as a consumer, complete artistic control over what you want to output. You can have different styles that Midjourney would otherwise not be very good at. This is me in Minecraft. A friend of mine generated this yesterday. I really like Minecraft, and I am a big fan of Hermitcraft, actually. This is, you can't really do this with Midjourney. There's a lot of hacks necessary for this. There's these folks on the internet. I like this guy. I don't know how to pronounce his name, Ilyasavil. He's insane, he's crazy. He's done ControlNet. So ControlNet is this basically hack on Stable Diffusion that allows you to control its outputs by inputting, like, let's say, a depth map. Like, I could take a picture of this room, create a depth map, and then put wizard hats on everyone, and it would actually capture the location of every single person because you're controlling it with ControlNet. So all these cool hacks are only possible because of the open source community, and it's hard for a large company to compete. And a quick time check. And I'm going to keep on going on. Let's see, actually, yeah, that's right. That's a MacBook. MacBooks do things. You know what? We're done with this guy. We can just close him. Yes, Yacine learns how to use a computer. what's really cool about this approach of, there's a big explosion, and because people don't have VRAM, they figured out how to use very little VRAM. There's something called parameter efficient fine-tuning, and this is the same thing for language models, where you don't need that much compute to fine-tune a model yourself. And I can explain a bit about how it works. You have dxd amount of numbers that you need to update. That's harder. Matrices are cool. If you multiply an R by D and a D by R matrix, you get an R by D matrix. I'm kind of hazy on the linear algebra. We'll ignore that. But basically, you need to do a lot less number updates, effectively, to train a model to update this amount of numbers. This works, surprisingly. And this is how most people actually train stable diffusion models in the wild. And what they then do is they actually merge the weights back. So they actually do the updates. So they multiply out, get this D by D matrix, which is the updates, and then they apply it on the pre-trained layer. And then that becomes their model, which is trained to do a certain thing. And this makes you not need an H100, and it actually makes you able to do this on a single 3070, 3080, a lot of the cases. And this is why you see all these character stable diffusion model generators. This is cool. People usually merge them. I don't like it when they merge them, though. Because when they're not merged, what you can do instead of swapping the models out is you can swap out the actual LoRa adapters. So this is called LoRa. You can read the paper. It's called low rank approximation adapters or something. And these adapters, which are very small tensors compared to the actual update tensors, you can train them and you can compute them in real time, and it's really not that expensive. And you can actually batch through this. So you can do this whole operation at once, and you can actually speed it. People have put up special kernels to do this really fast. So what you can actually do is, again, if you have a job queue, you can inference 5 different models off of the same GPU for 5 different users at the same time, basically increasing your generation speed by a large degree. And this works for language models too. So it's a friend of mine, and you can kind of see the text being generated at the same time. This is actually really hard to do. Yeah, it's awesome. So more users, less compute, and the capital advantage of large venture-backed software firms is dissolving every single day. Good news for non-VC-backed folks like me. This is the paper I was talking about. It's called SLoRa. These mad lads wrote their own CUDA kernels to do this operation very quickly. Yeah, awesome, awesome, awesome. And you can kind of see here where you actually don't need that much memory to store these adapters. And this is like having 3 different models, where you have the original model and then the two modulated models. Yeah, and you can even, there's like an endless amount of hacks if you just refuse to use different models. You can use Stable Diffusion to generate depth maps. So instead of wasting very precious, very precious VRAM, because that is the thing I find myself limited by a lot of the time, you can just use the thing that you're already using to generate sunglasses and be like, well, why don't you just generate depth maps instead? So this has all sorts of advantages. You just have to have less components in the system tends to be better. Yeah, and that's going to be my last slide. So yeah, yeah, this is how you don't die. You push as much inference as you can to the client. You reduce VRAM costs by repurposing parts of your model, and then you pray that things continue to get cheaper and better because you are betting your whole company on it. Yeah, that's Dingboard. So hope you guys liked my presentation. Do you guys have any questions? I will run over and give you the microphone.
I have a question.
Yep.
So it sounds very too good to be true. I'm a solo guy as well, and pushing inference to the client and get free compute. That's great. Have you ever had any complaints about people's computer freezing out or their battery life gets bad or something?
Not yet. I will, because I plan to push that much compute out. But I'll just ignore them because there's more users that don't care. I will warn them if I'm using too much power though. Please use Dingboard. I won't blow up your phone. Hopefully that actually answers your question. A lot of it is push and pull. So this is a hack. So one of the tricks I've done with Dingboard is I have an open channel of communication with my users. So if I break something, I don't really need tests because they will complain immediately. And that really helps. So I haven't had anyone complain yet about freezing. I've actually heard mostly good things about its performance. And I think it's because I'm lifting the work to other threads. Yeah, hopefully that continues. Yeah.
Hello, just a quick question. Have you tried TensorFlow.js?
Yes, that's a good question. That's a good question. Yes, I have. I had to look at TensorFlow.js because I was trying to use WebGL and they didn't. So ONNX did not have the correct ops implemented. So I was looking at TensorFlow.js and that was yesterday at like 6 p.m. And I haven't decided whether I'm going to use it or not. Based on my observations, I feel like ONNX is going to get more support over time. And I'm probably just going to ignore using WebGL for now because WebGPU is getting so much more support. And WASM is good enough. And honestly, the thing that's killing me is not really the inference speed, it's the compatibility issues. So if I go WebGPU, then a lot of people like Chrome on Linux doesn't support WebGPU. Yeah, excuse me. It's a very good question, though. Any more questions in the back? No? Oh, there we go.
What's the actual cost of ONNX, or how much does it cost to actually generate a meme?
So the cost of ONNX is for me, it's zero. Maybe the carbon emissions from a laptop, but laptops are getting pretty efficient. It's just the software is completely free and open source. Yeah, it's free beer. It's pretty incredible how much stuff there is just for free to use. For me, my costs are basically $2 an hour for an H100 server in Texas. That is all I'm ever going to get. My plan is for this month to get off of that and then move to a 4090 in my basement. That's the plan, and which will cost me electricity. Yeah, good question.
You mentioned that you weren't concerned too much about your image segmenting client side, but I would assume that it would reduce, take a little more memory and stuff. Have you looked into that?
So actually, the image segmentation right now mostly happens. So most of it right now happens. So depends on how you define most of it. Most parameters are actually in the back end, but I'm in the middle of implementing it for the front end, and yeah, it's going to be. The great thing about that is I can just serve it off Cloudflare. I don't even need a web server. And that gives me guarantees, because that's 90% of the use cases anyways. But yeah, I can put the whole thing on the front end. I mean, it's really just about efficient SAM and this continued downward exponential of continued halving of inference costs has been a boon for me. And yeah, it's going to fit on a browser.
How excited were you when you read the LCM paper? Because
Oh.
when I saw the tweet, I was like, oh my god, it's a big deal, and I started sharing that with friends. But
I cannot believe that Midjourney and other image gen companies are asleep at the wheel. They're asleep at the wheel. Come on, guys. I don't think people really. I think people who aren't excited about it. So here's my theory. My theory is that the Midjourney guys, they have such a different architecture that's too hard to port it over. And I think that all the other image gen companies are just too slow. Keep up. And the space is moving really fast overall, so it's hard to keep up with everything. It's we got LCM, and then immediately after that, we got one-step turbo stable diffusion. And you kind of have to measure your bets at which thing you're going to take up and what the trade-off is. But I will give folks advice here. One dimension that you can definitely win people on is latency. Latency will just completely kill user retention.
I just wanted to make a comment because you're trying to save money and everybody can. The major providers provide lots of free credits too.
Yep.
So for credits, so.
Yep.
You can burn that pretty quickly, but it's a good start.
Yeah, so actually I'm wearing a Lambda Labs t-shirt right now. Proof. And that's because they gave me $8,000 in free credits. All I have to do is wear a t-shirt. I was going to stream it today, but I didn't. So I still owe them like 3 videos, but I actually would recommend using Lambda Labs. It is very good. Do not go for, don't go for people who like will give you a model because models change too fast. Go for GPUs because then you can change the things as like the sort of platform, the field changes. That's my advice at least. Yeah.
Just a small question. So, does your client or like your customers, do they have to like turn on the experimental feature in the Chrome to have GPU running?
So I've actually like realized that they had to do that, and I've explicitly chosen to do WASM instead, which is way slower, but I'd rather have the compatibility. So that's where I'm at right now, like just using WASM and trying to get as much as people as possible. I've had no complaints as well, so yeah.
Stand in the middle, we're filming you.
Oh, right. Oopsie. Hello. And any more questions?
Have you tried run pod.io?
Sorry?
Have you tried run pod.io?
So have I tried run pod.io? No, I haven't actually. And yeah, the run pod.io and like Vast AI, it's pretty incredible to see this like secondhand market. I don't know what run pod.io. I'm assuming it's like Vast AI, but can you like rent like GPUs or?
You run GPU and execute a container.
Okay, yeah.
And you have like a connection.
Yeah, that's like incredible. Like there's like this whole secondary market of like consumer GPUs. I mean, we're really hurting for GPUs out here. Yeah, yeah. Yeah, thank you. Hey, thanks everyone.